There's three cases I want us to take a look at. The compound in front of us being the first case. So according to the exam guideline, the branch doesn't take preference over the halogen. The halogen doesn't take preference over the branch in haloalkanes. So how do we name these compounds? Let me go ahead and show you. So the first thing, we will identify our longest carbon chain, which will be easy to do in this problem. So let me just go ahead and do that. There we go. We have our longest chain, right? Now we need to number our carbons from the side closest to the halogen or closest to the branch. So if we start counting from the left, we're gonna have a branch on the second carbon. And then if we start numbering from the right, we're gonna have a halogen on the second carbon. Okay, so in a situation like this, what do? We have chlorine in between the branch and the halogen. It is right in between. If you start counting from the left, it's on the third carbon. If you start counting from the right, it's on the third carbon. So chlorine is playing no role in how we're gonna name our haloalkane. In a situation like this, we would start numbering our carbon from the right. So we would have 1, 2, 3, 4, 5, right? We're doing that because B from bromo comes before M from methyl. So the alphabetical significant. We're gonna start by now. We're gonna number our carbons from the right hand side. So let's go ahead and do that. We have bromo on the second carbon, we have chlorine on the third carbon, and we have methyl on the fourth carbon. So the name for this haloalkane would be 2-bromo dash 3-chloro dash 4 methyl pentane. Pent for the 5 carbons in our longest chain, ane the suffix of haloalkanes, 4-methyl, that is the branch we have on the fourth carbon, 3-chloro, the halogen we have on the third carbon, and the 2-bromo, the halogen we have on the second carbon. So this is the name of our haloalkane. Let's take a look at this structure. The first step, obviously, is to identify the longest carbon chain. So let's go ahead and do that. So this is going to be our longest carbon chain. Starting with this carbon, there we go. And this is what we have. Right. So there we go. We have our longest carbon chain with 6 carbons. Okay, if we start counting from the left, we have 2 branches on the third carbon, and then if we start counting from the right, we have a halogen on the third carbon. So where do we start numbering our carbons, from the left or from the right? Well, you might be tempted to say, from the previous example, we chose bromo because it comes before methyl. So in this case, we shall do the same because bromo still comes before methyl. But that is actually not correct. That is not what we are supposed to do in a situation like this. Let me show you why. Let's say we start numbering from the left, right? If we start numbering from the left, we're gonna have bromo on the fourth carbon. So we're gonna name our haloalkane as 4-bromo dash 3.3 dash dimethyl hexane, right? That is how we would name our haloalkane if we started numbering our carbons from the left, right? So this is from the left, how our IUPAC name will look like if we start numbering from the left. But if we start numbering from the right instead, we would have 3 dash bromo dash 4.4 dimethyl hexane. This is if we start naming from the right. So there's something I want to show you here. If we start naming from the left, we have 4 plus 3 plus 3, which is 10. And then if we start naming from the right, start numbering our carbons from the right, we have 3 plus 4 plus 4, which is equals to 11. So this is 10 in total, and this is 11. So we are actually gonna go with this first one because it leads to the least number, right? So this is what I was referring to when I say sometimes it's not the alphabetical order that is gonna decide. Here's another example of that. We have a haloalkane with 1, 2, 3, 4, 5, 6 carbons in the longest chain, of which if we start counting from the left, we have a halogen on the second carbon. And if we start counting from the right, we have a branch on the second carbon. So in a situation like this, once more, we're not gonna start numbering from the left because of this fluoro that we have on the third carbon if we start numbering from the right. So we would actually start numbering from the right because ultimately we're gonna have the lowest numbers in our IUPAC name compared to if we started counting our carbons from the left. Let me go ahead and show you. If in this case we start counting our carbons from the left, we're gonna have 2 bromo, and then our fluoro would be on the fourth carbon, so 4 fluoro, and our branch would be on the fifth carbon, so 5 methyl dash hexane. No, there's no hyphen, hexane. So this is if we start numbering from the left. Let's take a look. We have 2 plus 4 plus 5, which is 11. Now let's start numbering from the right and see what happens. From the right, we're gonna have 5 bromo, and then fluoro is on the third carbon if we start numbering from the right, so that is 3 fluoro, and then 2 methyl hexane. So let's go ahead and take a look. 5 plus 3 plus 2, this is 10. Yeah, so clearly in a situation like this, we need to start numbering our carbons from the right hand side. If you like this video, you will definitely love my course. Go ahead and click the link on my bio and you will land on this page. You will not only find the past exam questions, but introduction videos where I break down complex concepts into small pieces that are easy to digest. It is very important in grade 12 to stay ahead of your teacher, and this is what this course is for. It's very easy to navigate through the course as videos are arranged into collections. You can clearly see that we have electrostatics, work energy and power, Doppler effect, so on and so on. Do you maybe need help with study tips and creating your own timetable? We can talk about that inside the course and I can help you out. It doesn't even take a minute to join. Can't wait to hear from you.